is hacking mobile devices. Now, I ought to mention a very frequently asked question is students are trying to get into CNET 123. And I got an answer, which is as I thought, those courses are full, no more people can be added, but if you were unable to get into the course that you want, it would help us if you'd write a letter to the administration. All of our courses were full right from the start this semester in our department because they've cut the staff so much we're not offering enough classes anymore. And yet the administrators don't believe that when we tell them. They think we're unproductive. So they don't believe students are unable to find the right class. So if in fact you were unable to get the class you want and had to take something else, then I have a sample letter here. It'd be nice if you'd send one of these to people like the chancellor and other administrators telling them you tried to take a class and you couldn't, and what happened, so they know, they believe you exist. They would like to pretend there is no problem, but there is definitely a problem. But they will only believe that there's a problem if they get letters from students. So I put that on my page here, right below the classes, an appeal for more classes. Let them know if this happens to you. All right, anyway, this is CNET 128. This is the second class meeting. The first one I just gave a lecture I'd done at DEF CON about the worst mobile apps, and demonstrated the projects where you get an Android emulator going and you get a proxy going so you can examine the network traffic going into and out of it. And one student afterwards, with a Mac M1 just like me, was unable to get it to talk to the proxy, and I was unable to make it work. So there's something out of control there. And I mentioned the solution in case this happens to other students. I'm using Android Studio Emulator, which usually works, but if for some reason it doesn't, and like I say, for at least one student, it just won't work, you can try these alternative Android emulators down here like Genymotion, which is what I used to use. So that's why I left these up here. This is what I used to use, because the Android Studio Emulator used to be very rudimentary and not much use. It got better, and the last time I taught this course, pretty much everybody could get everything they need through the Android Studio Emulator, but all these emulators are pretty buggy and inconsistent. So if one doesn't work, try another, and let me know. It is very common that they have defects and don't work very well. That's why I got another student here doing the right thing. You can just use a physical Android phone if you have one. That's a perfectly fine solution. It will be a lot more reliable than an emulator. Just use a real phone to practice on, and that works too. Anyway, all right, so, and we're not going to be using any malware in this course. We're just going to be using standard apps from the App Store. They're messed up enough, but they're not exactly malware, so you wouldn't have to be too afraid to put them on your personal phone. But it's better not to do these hacking projects on a personal phone with your personal data, just as a general practice. But we are not working with real malware, so it's not as important as it is in, say, the malware analysis class, which is happening on another night. All right, so let me just check and see if there are any questions. No, nothing new. All right, so let's pick up. So we've done the introductory stuff, and now today we're going to start going through the textbook, which is chapter 1 and beginning chapter 6. The textbook goes through iOS first and then Android, but since our hands-on projects are with Android, we're going to do Android first and then do iOS later. So we jump from chapter 1 to chapter 6. So I got some slides. There we are. Let me get rid of this Zoom. We don't need that till later. All right. Okay. So, all right. So we talked about this, making an Android environment and how the applications work. So the best thing is Android Studio for most students running on any operating system. This is what you use to write apps, and you can also use it to test apps. Now, you have a host operating system underneath. In general, Mac or Linux is much better than Windows, although Windows is getting much better at supporting Android, and now Microsoft is an investor in Android. They get royalties from Android, and they're trying to integrate it into Windows, the modern version of Windows, like Windows 11. So presumably, the Android emulators will be running better on Windows than they have in the past. In the past, we've had a lot of trouble. BlueStacks is the one I found to be best a few semesters ago. Like I say, last semester, the best one for everybody was Android Studio. This semester, I don't know. It keeps changing. The operating system keeps changing, and the quality of the Android emulators keeps changing as they fall out of date. ADB is the main tool you use. ADB is a command line tool, Android debug bridge, that lets you control a phone through the command line. And it's very useful. You can install apps, you can pull files off the device, you can get a command line shell on the Android device, and then you can traverse and modify the file system, read the logs, so it gives you complete access if you have rooted your phone, which we'll do. So you can monitor processes, manage multiple emulators, and you can package source code when building apps, which we're not going to use, but it is an option. And Genymotion, for example, one emulator has 133 different emulators available. The Android Studio has many different types of phones it can emulate. For what we're doing here, it doesn't really matter which one you use. We're doing generic things. All right, so most emulators have rooted phones, which means they are not the kind of standard handset you use where you run as a user, but you're not root. Most emulators run rooted phones. The Android Studio emulator can run rooted phones or unrooted phones, and we'll see that. They do have limitations, though. No physical hardware input or output. They cannot make phone calls, so you cannot really test all the functionality of every app in an emulator, the way you could if you used a real phone. And so VirtualBox is what's really being used for almost all the Android emulators, except for the one called in Android Studio. Almost all of them are running VirtualBox, and that is the problem. VirtualBox is an open source hypervisor to run virtual machines, and the developers take one version of VirtualBox and then modify it, and then distribute it, and then after a while it's no longer compatible with the drivers and hardware on machines, and that's what causes all the problems. The emulators did work at one time. That's why I had a student who was very determined and managed to get everything working by rolling back versions in VirtualBox until they got a version that would actually work matching the operating system, and by blocking Windows updates. It takes things like that to really make these emulators work. It's not easy and not efficient. That's why Android Studio is usually a much better solution. All right, so Android applications. Android run essentially on Linux. The Android operating system is modified Linux. It looks very much like Ubuntu inside, and then it runs a Java virtual machine in there, a Dalvik virtual machine they call it. So the apps are mostly written in Java, which is a cross-platform language. This means apps are surprisingly inefficient and insecure. Running through a Java virtual machine means they're going to run slower, and it means that you effectively have the source code of every app, because it doesn't compile down to machine code. It compiles down to device-independent bytecode called Smalley, which is very easy to read and which can be completely reversed to Java. And the same thing, by the way, in the Windows environment is true of .NET. .NET is Microsoft's competitor for Java, and it has exactly the same issues. If you have a .NET application, you have effectively the source code of the app. And developers frequently do not understand this and leave secrets in the source code and think you can't find them. For example, something like half of the Android apps I've audited make the mistake of using encryption with a private key and then trying to hide the private key on the device somewhere, and I can just read your source code and find out how you made the private key and where you put it, so this is stupid. But people who use things like C# and C++ in a Windows environment, like for x64, they get used to the feeling that when I compile the code, nobody can see the source code anymore. And that is true to a higher extent for that kind of app, but for Java and .NET, it is emphatically not true. You can take the code you've distributed and completely reverse it right back into source code with freely available tools. So you shouldn't imagine that you're hiding anything by putting it in your code. I'm checking for comments here and not seeing any. Okay. All right. So on Linux, every app, on Linux, you'd log into something like Ubuntu Linux. You have a username, and every app you launch will launch with your privileges. So all the processes run with the same user account. That same thing on Windows. On Android, it's completely different. So here's an example of Ubuntu running several apps. And if you do PS-UT here to see the processes, you see all these processes are running as student. Student has launched several processes. Everything you launch runs with the same user account. That's the way normal multi-purpose operating systems work. But Android is different. Each app creates a new user account and runs with a different user account. This is at the heart of the Android security model. That's the idea. Each app is supposed to have its own private data directory which other apps cannot see. And nobody can get in there except root. So if you go into Android, make a shell and do PS-A, you'll see there are several apps running, and each app is running with a different user account. A47, A7, A105, all these, a different user account is created every time you install an app, and that app runs as this user, which is separate than the other users. So that is the so-called sandbox that isolates one Android app from another. Now there's a home directory for all apps, data, and in that directory you have subdirectories for every app. So I've got this Ask a Lawyer, Small Business Marketing, File Manager, an Amazon app, a backup app. Each app has its own directory, own subdirectory, owned by a different user account, which is where that app stores all its data, in the data subdirectory. All right, the APK file is the way apps are distributed. One file, it's just a zip archive. It contains everything, the code, the resources, and the metadata, all zipped into a container, and that is stored on your phone. I don't know why they do this. I was surprised. If you install something like a Windows app, you download an installer that's like an MSI file, you run it, and then you throw away the installer and use the app. Android does not work that way. It saves the original APK file for some reason, I don't know, but it's very handy. You can just totally download it from the phone and have the APK file. Then it unzips it and runs it, so you have 2 copies of every app, a zipped version and an unzipped version. Seems like a waste of space to me, but that's the way it works. So there are some tools here to move from one language to another, but anyway, we're going to do this mostly in Conjure Studio context to make it easier. We will use jar signer. Jar signer is very important. Every Android app is signed. Now, code signing is a powerful security measure for Windows apps, and for that matter, Mac apps. Normally, to sign a code, you have to get a code signing certificate from an authorized certificate authority, which is not easy. It took me months of arguing with them to get mine. You have to convince them you're legitimate, that you're writing code. Then you sign your code with that, and anybody that installs it, the installation process checks to make sure that signature is valid, and so you know who wrote the app and that the app has not been modified. However, Android apps completely mess this up. Every app has to be signed, but it is not signed by a legitimate certificate authority. It's self-signed. So you generate the signature and sign it yourself, and it's not verified anywhere, so I can claim to be the US government, Apple, and anything I want. It doesn't matter. And then the only purpose of the signature is so that when you have an update, it can compare the signature and only accept the update if it matches. And that's why there's so much malware in the Android ecosystem. If I put malware in the Android store, in the Google App Store, and they catch me and ban me, I can just make another account and put malware in there again. And they can't do anything about it because I never had to prove my real identity or anything. It's kind of stupid. The Apple Store is very different. You have to pay a fee and you have to prove who you really are. And if you put malware in the Apple Store, they will kick you out and you can never get in again and you can't make any money. And there's real money in selling iOS apps. So developers do not want to get kicked out of the store, so there's almost no malware in the iPhone App Store. But the Android App Store has persistent, recurring malware in it because it's a free ecosystem. It's like based on sort of Linux, where they don't kick people out. So anyway, that's a thing to be aware of. So here's what's in your app. You have assets, resources, libraries, a meta-inf directory, which I think is where the signature is. Then you have a manifest file, which includes global information about the app, like some global variables and things like the permissions, whether it's going to have access to the network card and the contacts and things like that. And then classes and resources here. Assets, resources, libraries. Here's the meta-inf. That contains the certificate of the application and a list of hashes. And like I said, the Android manifest, which is usually the first thing you look at. And there's an Android manifest. It shows you information like down here is its permissions: access network state, access course location, access find location, and so on. That's the main thing you see in here is all the permissions that your app has. And as you probably know, when you install an app on a phone, it will pop up a box saying, this app has these permissions, is that okay? And that's what's going on here. This permission structure, by the way, is quite limited and buggy. There are a lot of ways to trick apps, to trick Android into giving you permissions that the user didn't really agree to. It's one of the more common weak spots in security. All right, so classes.dec is executable files, and here's strings and other resources there. All right, so when you install a package, there's a thing called the Gtalk service, which maintains a connection to Google by pinned SSL. This is a really good idea. There's normal, by the way, it's not SSL, it's TLS. SSL was the original secure internet connection, and all versions of SSL are insecure because they're old and broken. It's really TLS is the replacement. Pinned TLS is even more secure because normally when you make a TLS connection, for example, if you go to a browser and you type in something like yahoo.com, you connect to Yahoo, and it's probably secure, I imagine. Yeah, connection is secure. What this means is I connected to Yahoo, they sent me a digital certificate, and my browser verified the certificate with a trusted third party, so they know I'm really talking to Yahoo. But it could be any of the trusted third parties. There's 100 known trusted third parties or so, including some pretty untrustworthy things, like the main government of China and other places that really aren't all that trustworthy. If they didn't include it, you couldn't get to any Chinese websites, but the way your browser is configured, a random Chinese authority could sign a site telling you it's Yahoo, and your browser would accept that. This is a fairly common attack people worry about. So to prevent that, you use certificate pinning. Not only do you make a TLS connection, you also tell it which certificate authority must sign it. So it's now pinned to either that exact certificate or that certificate authority, so you have an even higher degree of confidence that you're actually talking to the right server. And that's what the Gtalk service does. It makes a pinned connection to Google. So you really know you're making a secure encrypted connection to the real Google, and that's where you get stores in Google Play. That's where you get apps from Google Play. However, since it's an open source community, there are a bunch of other app stores. Amazon has one for the Kindle, other people have them, and they're all over the place, and there's bulletin boards where people post apps. You can just host an APK file anywhere, and you can install it from anywhere. This is not so easy to do on the iPhone, which is part of what makes it so secure. But Android is the free operating system, so you can freely distribute apps. And of course, one area that really gets hurt is the people in mainland China, because the Great Firewall blocks Google services, including Google Play. So you have to install the apps from unauthorized sources. All right. So you can install an app from ADB, you can push a file on the device, you can pull it down, you can forward a TCP port from your local machine onto the phone, and you can see the log on the phone, and we'll do all these things in the projects. BusyBox is very useful. If you have small Linuxes for Internet of Things, including Android phones, they typically do not contain common command line commands that you need in Linux, like ifconfig and other ones. And BusyBox is a single binary that includes a whole bunch of common Linux commands. So you typically install it if you want to actually do things on an Android device. And it has these common commands. This is useful for almost any kind of hacking, any kind of small devices. All right, so the standard Android tools, there's a package manager that will show you all the packages and where the APKs are. You can view the system logs, you get system properties, you can get the status of the services. All these things are fun. And there's a security assessment tool called Drozer, which I used to use in this class. I think I probably took it off. I think this has not been maintained. What it was an attempt to write like Metasploit for Android. But now you can use Metasploit itself, and I think I'm no longer doing the Drozer tools, so I'm just going to talk about it remotely. Drozer had you put an agent on the phone and then remote control, and the point of Drozer was to test this attack. This is a fairly common method of attack on Android phones. You trick the user into installing a malicious app, because there's a lot of malware in the store. After you do, then you use that app to attack other apps on the phone. So you're already on the phone, but you have a different user account, and you're trying to find a way to break into other apps. That's what Drozer does. You put an agent on the phone, you then remote control that agent, and now you can perform attacks of this sort. So I had some projects like that, but I'm not sure they've been kept up to date. We may not be doing it, but it looks like this. You have a console on your device, and you have an agent running on the phone. And now from that agent, you can scan for other apps and look for signals, for example, inter-process communication signals. There are various ways for an app to send a signal to other apps or the operating system on the phone. And so there's 4 parts to applications. There's activities, which are the visible screens you see. There are services, which are things running in the background that do not have a graphical user interface. They just provide some kind of service to the app. There are content providers, which are databases like SQLite, some kind of store of data, and there are broadcast receivers which can detect events. For example, an incoming SMS. This is why when an SMS comes in, something will pop up on your phone. Some apps on your phone are listening for an SMS, and when the SMS comes in, they activate and do something about it. Same thing with email and other things that come in. So you can see the running services here. You can get there in developer options and see running services. And you'll see all the components. All the components are listed in the Android manifest. So here you will see the main activity. Here's an activity. And in there's an intent filter. So here's an activity, and it's the launcher. So it has an intent here. So this is when you When you tap the icon to launch the app, it goes for the one that's marked launcher, and that's the activity that launches. And there may be other activities in the app, but that's the starting page of every app. All right. And it also shows permissions if there are any, and we'll talk about more of them later. You can configure permissions limiting who has access to these things. Intents are a way to use messages between apps. This calls binder, and so you can generate an intent with this sort of code, and this will launch Google, sending a Google intent to the operating system, which will then open in whatever the default browser is. If you have only one browser, it will just open in the browser. If you have multiple browsers, it will open a box saying, which browser would you like to use to open this? That's what happens. The same thing would happen on a Windows machine if you went into the command line and just typed a URL. It would open it in the default browser or perhaps ask you which browser to use. All right? And there are implicit intent. This is an intent that does not specify what app to use. It just says, send this signal to the operating system. And then it will use whatever app is available. You could also specify, open this data in this specific app. But it didn't do that. It just said, open it in the generic one. All right. And you can have an intent filter. This is what you'd have on the other end to show that you can open a web page. You would have an intent filter accepting HTTP. The thing that determines which app will get it is the schema, the first few letters before the :/ in URL, HTTP. So HTTP things will open in the web browser, and there are other ones that are created, like Skype has its own intent filter. All right, and here's one that would specifically go to just the Android default browsers. So it takes google.com and it goes to COM Android browser, which is the default browser that comes with the phone. So it's going to open this, but not in any old browser, but in that specific browser. So you can do that if you want to when you're writing your code. All right, so a single virtual machine starts when the OS boots and a Zygote process listens for app launch requests. Each app after that launches fork. Fork is the way this is the way Unix has worked forever. There's one process, and every other process is a fork of the first one. When you fork a process, it starts another process identical to this one, which can now evolve differently. And that's why originally, I don't know if it's still this way in Unix, but originally in Unix, the first process was called init. And everything else was a fork of init, and therefore rootkits would modify init. And now every process on the box will have the modified code and be infected. And it sounds like a lot of that functionality is still running in Android. So let's try a Kahoot. Let me check for questions. Let's see. I don't need Yahoo anymore. Okay, no new questions. All right, let me get to my Kahoots, which should be here. Somehow I lost them. All right. Yes. All right. There we are. All right, this is an extra credit thing. People answer a quiz, just helps prevent people falling asleep so much. So go to kahoot.it and put in that number if you want to compete. And I've got a place ready to store the winners. Looks like we got everybody that's coming. All right, what's the most popular mobile OS? It is Android. I didn't see that go by in the slides. I did chapter 1, right? Oh, I did the wrong, I did the wrong chapter first. Okay, let's hold off on the Cahoots a bit. All right, I see. Well, I can switch to the other Cahoots. All right, we're going to cancel this one. That's the 6A. You're right about that answer, of course, but this is chapter 6A we just did, so we'll do these Cahoots. Such is life. At least they're not from the wrong course. I've done that too. If anything can go wrong, it will. Enrolled, I'm not, yeah. Anybody's welcome. You don't have to be enrolled as far as I'm concerned. The only penalty for not being enrolled is you won't get any official college credit. What's that? Yeah. And a lot of people don't care about community college credit, which is fine. Just don't tell the administration. It's one of the many rules I'm breaking. So. They have an awful lot of rules to prevent all progress, so that's why you have tenure, so you can break the rules. Liz E. No, it can't be the Liz I'm thinking of. All right. Let's try this one, see if it actually matches the lecture letter. All right, the IDE for app developers. Okay. That's Android Studio, of course, just like Visual Studio. All right. Which tool lets you install apps? ADB, Android Debug Bridge. All right, what folder contains an app's signature? Meta-Inf. All right. And which process used pinned SSL to connect to Google? That's what they call it. They should call it pinned TLS, but they forgot to ask me. That's the Gtalk service to talk to Google. All right, what module runs IPC? All inter-process communication. This is also present in all operating systems, so one app can talk to another app, and it is commonly a source of security vulnerabilities. Because since one app can send a signal to another app, which does something, you can often send a malicious signal, which is misunderstood by the target app, and that's what leads to a lot of exploits. All right, and what app components are visible to the user? Okay, those are the activities. All right, here's the winners. All right, real name. Also a presidential candidate, perhaps not the same person. And these people, I think I know who they are from previous classes. All right, good. All right, well, that was 6. Now let's take a look at 1, which will be a little more elementary. Oh, I'll make a separate video anyway, so I can put the videos in order, even though the lecture was not in order.